Hi everyone, this is Dr. Ramanna, Assistant Professor of Physics. So today I am going to talk about destruction of superconductivity by magnetic field, or we can say that the critical magnetic field, and it is denoted by Hc. See, what do you mean by critical magnetic field, which we have already discussed in the last class? See, the minimum magnetic field is required to destroy the superconductivity is called critical magnetic field. Okay, we know that some metals below critical temperature lose their resistivity and they become superconductors. But whatever may be the temperature, if a strong magnetic field is applied to the superconductors, they lose their superconductivity property and become normal. See, what I mean to say, whenever we cool the temperature of the materials, at critical temperature the materials becomes superconductors. It becomes from normal conductor to superconductors. At Tc, the critical magnetic field is 0. The field is 0. See, here there is a graph, that is Hc versus temperature. Critical magnetic field versus temperature. Critical magnetic field is in y-axis, temperature is in x-axis. See, there is a curve over here. Outside the curve there is a normal conductor or normal conducting state, and inside the curve there is a superconducting state. In this graph, below Tc, it may be any temperature with respect to critical magnetic field. For example, if I take mercury, its critical temperature is 4.2 Kelvin. If we further cool the temperature of this mercury, it will go beyond 4.2 Kelvin. At 4.2 Kelvin, we need zero magnetic field to destroy the superconductivity. If we go further below, for example 3 Kelvin, so at 3 Kelvin, what is the magnetic field we require to destroy the superconductivity? So, corresponding to y-axis, for 3 Kelvin, corresponding y-axis, how much the magnetic field we need to destroy the superconductivity. So, that is critical magnetic field. And if we go further decrease the temperature of the material, suppose 2 Kelvin, again it needed the required magnetic field to destroy the superconducting nature. See what happens here, when you decrease the temperature below Tc, okay, so we need the temperature, the critical magnetic field will be varying. It's nothing but what, the temperature increases below, the temperature decreases below Tc, the critical magnetic field will increases, right? See, as temperature decreases, the critical magnetic field will be increases, right? See, at critical temperature the critical magnetic field is 0, so that is Hc of T equal to what? 0. The critical field Hc is a function of the temperature T. See, if you want to find the critical magnetic field at a particular temperature, there is an equation. So that is Hc of T equal to Hc of 0, 1 minus T divided by Tc whole square. So here Hc of 0 is the critical field at 0 Kelvin. That's nothing but what? At origin. Next, the Hc of T is what? It is the critical field at temperature T. It may be any temperature below Tc. Then Tc is what? Critical temperature at 0 field. Usually the normal conductor becomes superconductors at Tc. At Tc, the critical field is 0. Okay, so we will discuss about two cases over here. One is at T equal to 0 Kelvin, T equal to 0 Kelvin. Okay, so now how much magnetic field we required to destroy the superconducting nature? So fill the temperature 0 in this equation. Hc of T equal to Hc of 0, 1 minus T is 0. So 0 divided by any number, so that is 0. So what is the remaining? Hc of T equal to Hc of 0. Okay. So here both are equal. Hc of T equal to Hc of 0. So take second case, T equal to Tc, the temperature equal to critical temperature. So at the time Hc of T equal to Hc of 0, then 1 minus 1 divided by 1. So that is 1. 1 minus 1, 0. 0 into Hc of 0. So that is 0. So Hc of T equal to what? 0. Okay. Now the resistance in superconductors can be restored by the application of the magnetic field greater than the critical field. See, in this figure, in this graph, inside the curve, the material is in superconducting state. Then outside the curve, it is normal conducting state. When the temperature of the specimen increases, the value of the critical magnetic field decreases. The critical field is different for substances. Okay, so this is all about destruction of superconductivity by magnetic field, or we can say that critical magnetic field. Okay, thank you.